Right now, as you read these words, you're actually performing an act of incredible complexity. Information flows from this screen through your eyes and into the intricate network of your brain. Your mind processes the shapes of these letters, converts them into sounds, and assembles them into concepts. This is the chasm that separates mere information processing from the subjective reality of consciousness, the internal movie that you are living right now. The idea is that if you build a system with enough interconnected nodes and processing power, consciousness will simply switch on like a light bulb finally receiving enough current. But a profound and challenging idea from one of the world's most brilliant minds suggests this view might be fundamentally incomplete. This alternative proposes that consciousness is not just about the complexity of the connections, but about the very fabric of reality in which those connections exist. It argues that a crucial piece of the puzzle lies not in computer science, but in fundamental physics, specifically in gravity. This isn't the familiar gravity that pins us to the Earth, but a subtle quantum-level effect that might govern the collapse of possibilities into a single, definite reality. The theory suggests that consciousness is tied to a physical process that today's computers cannot, and perhaps never can, simulate. It hints that the feeling of awareness is a feature of the universe itself, harnessed by the delicate, specific architecture within our neurons. The dominant scientific theories of consciousness, such as the Global Neuronal Workspace, or GNW theory, focus on the computational architecture of the brain. GNW proposes that you become conscious of a piece of information when it is broadcast across a widespread network of neurons, making it available for various cognitive processes like memory, planning, and language. In this model, consciousness is a functional property of information access. They imply that if we can replicate the brain's functional architecture, its global workspace, or its integrated information structure, in a silicon-based machine, we will have created genuine consciousness. The machine would not just be an inner life, it would actually have one. The radical alternative, championed most famously by the mathematical physicist Sir Roger Penrose, argues that the computational story is missing the most important chapter. Penrose contends that human understanding, particularly our ability to grasp mathematical truths, possesses a quality that cannot be captured by any algorithm. This is not a philosophical preference, but a conclusion he draws from the deep logic of mathematics and computation, particularly Gödel's incompleteness theorems. This something else Penrose proposes is the physics of reality at its most fundamental level. Specifically, he points to the unresolved mystery of quantum mechanics, the measurement problem. This blurry state of potential persists until a measurement is made, at which point the system collapses into one single definite reality. Penrose suggests that it is not an external observer, but gravity itself that resolves this ambiguity. This process, called objective reduction, or OR, is a proposed physical law, not just an interpretation. The theory, developed with anesthesiologist Stuart Hameroff, is called orchestrated objective reduction, or ORCH-OR. It hypothesizes that this gravity-induced collapse is not random noise but is orchestrated within the brain, specifically inside tiny protein structures within our neurons called microtubules. These microtubules, the theory claims, can sustain quantum superpositions long enough for them to reach the gravitational collapse threshold. Each moment of orchestrated collapse, according to ORCH-OR, corresponds to a moment of conscious experience. He proposed that the perfect candidates for hosting these quantum computations are the microtubules. These are tiny, cylindrical protein polymers that form the cytoskeleton, or structural scaffolding, of every cell, including neurons. Their hollow, crystalline structure and the materials they are made of, he claims, could create an environment isolated enough to protect quantum states from the chaos of the cell. Each tubulin protein can switch between at least two different shapes, driven by the location of tiny quantum particles within it, known as electrons. According to the theory developed by Penrose and Hameroff, orchestrated objective reduction, or ORCH-OR, These tubulin proteins can enter a quantum superposition, existing in both shapes at once. This would create a large coherent quantum state, a form of quantum computation unfolding within the very skeleton of the neuron, shielded from the noisy cellular environment. The brain is not just a network of 86 billion switches, but a network of 86 billion quantum processors, each containing countless quantum bits. When this energy reaches a critical threshold, the system becomes unstable and spontaneously collapses into one single definite state, with no measurement required. It asserts that there is a specific calculable timescale for the collapse of any given superposition, determined by its mass distribution. And according to Orsh-OR, it is this very process, happening over and over inside our brains, that creates the flow of our conscious thoughts. The theory suggests this process continues until tau reaches a timescale that's relevant to neural processes, like, for example, around 25 milliseconds, which matches up with those 40 Hz gamma band brainwaves that are often linked to conscious perception. And according to the theory, this physical event, this moment of gravity-induced collapse, is a moment of conscious experience. The continuous flow of our awareness is proposed to be a sequence of these individual, objective collapse events, kind of like the frames of a film reel. The key lies in the central equation of objective reduction tau equals h bar divided by EG. So this gives us a crucial variable that, in principle, we can manipulate mass. If we could find a way to subtly change the mass of the components involved in the supposed quantum state without changing anything else about the system's chemistry or computational structure, we could see if it affects the timing of conscious processes. This leads to the design of what we can call the mass invariance test. First, you identify a neural correlate of consciousness, a measurable brain activity that's tightly linked to conscious experience. The prime candidate is the 40 Hz gamma band brainwave, which Orsh-OR specifically associates with the frequency of its collapse events. In the test condition, you increase the mass of the specific molecules that Orsh-OR claims are creating the superposition, namely the tubulins within the microtubules. A molecule built with carbon-13 will be slightly heavier than its normal counterpart, but it will form the same chemical bonds and participate in the same biochemical reactions. We could raise organisms or prepare brain slices in an environment where the essential amino acids used to build proteins are synthesized with carbon-13 or nitrogen-15 instead of their lighter, more common isotopes. This process, known as isotopic labeling, would result in microtubules that are physically heavier but chemically and structurally unchanged. It allows us to tweak the very parameter, mass, that Penrose's theory depends on, while leaving the computational architecture of the neuron, which the other theories depend on, almost completely untouched.